As artificial intelligence quickly becomes part of our everyday lives, the demand for processing power and the energy to fuel it is surging. Here in Utah, engineers, private businesses, and elected officials are building what they call the GigaSite, the world's largest data center campus in Delta down in Millard County. But Utah is also navigating a 2-decade-long drought, making water conservation a top priority for the public and for elected officials. So how do you run massive data centers without draining a limited water supply? John Kolar is the principal at Integra Mission Critical, and he's been working on that exact problem. John, thanks so much for joining us today.
Yeah, thanks for having me.
Let's start here. Tell us about your background and your role at Integra Mission Critical, and a little bit about the company and the role that it plays in the Utah GigaSite.
Yeah, so we are a design-build data center developer. So we design and build data centers. We have the unique position that we also design and manufacture all the equipment that goes, provides the cooling and the electrical infrastructure in the data center. So we're kind of soup to nuts, everything that needs to go into the data center. My role, I sit on the mechanical side, so mechanical engineer by training, and I lead the design efforts in and around the cooling systems, which hence the discussion around water.
So how are the GigaSite data centers being designed differently so that they don't come with such high water demands? How do you go about that?
So we purposefully designed them to be waterless. So literally your home, typical residential house will use more water than a large data center. That's all on purpose, right? We've designed all the systems in the building to minimize energy consumption and eliminate the need for water. So heat rejection, when you build a data center, every kilowatt of power that goes into the data center leaves as heat rejection. And we've designed all of that heat rejection to be dry equipment. So literally no water consumption at all.
That's amazing. I was going to ask you how, if you could give us a sense of how GigaSite compares to traditional data centers of the past. It sounds like it's night and day. Like you're saying, the only water that really gets used is in the restrooms or the kitchen sink in the break room. It sounds like
exactly right. So it's kitchen sink, it's the break rooms, it's the restrooms. That's it. Historically, everybody was making relatively very complicated data center design. Simplification is kind of our preferred method of doing things. Just greatly simplify the designs and doing that efficiently. So we make the equipment more efficient. We make the cooling equipment more efficient, which allows us to get rid of the need for water. Not long ago, and designs that are being done now by others, not by us, water-based designs are very common. The challenge is when you consume water in a data center, it's a lot. So by designing all of the mechanical equipment to be efficient without water, we're able to greatly reduce or just eliminate the need for water altogether. If we're comparing it to a wet system, the water consumption would be off the charts. But in our case, we get a great efficiency in our data centers without any water.
So how does this shift toward water efficient or essentially zero water data center cooling, how does that position Utah in the broader race to build infrastructure for AI and cloud computing? Because I think we're in a desert, other places aren't in a desert. Water is maybe a little more precious here than it is elsewhere. Does this sort of put Utah on equal footing with other places in the country, or how does this boost Utah's efforts to be part of building and powering the AI future?
So power is the critical component, not water, right? So that means all those places in the world that are dry are good. Cooler climates are also helpful, right? Appreciate you have a nice cool climate in the fall, for a significant portion of the year, right? And that allows us to run effectively without any refrigeration in that data center. Allows us to run without water and without any refrigeration, which really drops the peak power, which puts Utah in a pretty unique spot. There's lots of other places on the planet where you just don't have that advantage, and Utah is in a really good spot to do it. Data centers there aren't a bazillion people in a data center, right? It's a big construction project, and then a big data center employs maybe 50 to 75 people, and then a campus, you get to a couple hundred across the campus, but they are not a big tax on resources for the area.
So I'm going to get you out of here on this. Looking 5 or 10 years down the road, how do you see the GigaSite shaping both Utah's role in AI infrastructure and the expectations people have for sustainable data centers?
So sustainability is a big deal, right? So there's sustainability in everything we're doing from a design perspective. We're modularizing equipment and pre-manufacturing equipment, which helps from a sustainability play. The buildings get to be smaller as we take all the equipment and we factory build. We factory build all that heavy infrastructure, but it's a big deal to help long term with the sustainability of the sites. They should not be a big impact on the environment, right? They're not consuming any water. The energy consumption, while it's a bunch, is generated typically elsewhere and brought in. So it's really good for both the environment and for bringing, albeit limited, high-profile jobs to the environment or to the area.
So bottom line from this, Utah's got a lot of things going for it when it comes to building a massive data center campus like the GigaSite, and where water is a concern that people have had in the past. Doesn't sound like that needs to be a concern going forward.
Exactly right. Yep, exactly right. No need to worry about the water.
John Kolar, principal at Integra Mission Critical, has been our guest. John, thanks so much for your insight. Really interesting stuff and an amazing bit of engineering, I would imagine, as well. Thanks so much for joining us.
All right, thanks for the time. Appreciate it.
And don't forget, you can subscribe to our publication at wiredwest.ai for more conversations with AI leaders who are shaping the digital future.